Hello, welcome back. This one is going to be about the import and export tools. So generally the import and export tool is for migrating your GridDB database. If, for example, you had version 4.6, version 5 is very new and kind of breaking. So you couldn't actually just upgrade your existing 4.6 to 5.0 without some kind of data issues. So in this case, you would use the GridDB developed import export tool. So in this video, I want to showcase just the import first, and then we'll do export. I guess that's backwards, but we'll do import first in this one. So in this case, I will not be showing you data that came from another GridDB database, though that typically would be the use case. Whatever lessons you learn in this video, you can also apply in that import export from a new database scenario. But in this one, we're going to grab data that is coming in from Kaggle, a data set that we picked from online that's public domain. And then we're going to clean it up, wash it up in a way that GridDB likes. And then we will ingest all of that data in, I think, one command after we do all the cleansing. Okay, so let's first install the import export tool. So I believe you could just Google GridDB import export. Let's try that. Import export tools, here you go. So the repo is called expimp, so it's export import. And then I think we just got to clone this because the releases, I believe, don't have anything worth, yeah, it's just source code. So let's clone the repo and let's see if there are instructions on how to build. So basically you use the Gradle. Okay. Clone this, go in here, expimp, then we go to exp again, and then there's a Gradle, so we do the Gradle, and then shadow jar, I think. Yeah, shadow jar. Run this. Yep, it should be fast. I don't think it's that complicated of a tool. Bloat wise. So once this is done, let's look at the other instructions actually. So once this is done building, there will create a jar file within the build/library. Okay. And I guess that's basically it. So actually, no, sorry, that's not it. So we need to configure our properties file. So in this case, it's assuming we're in multicast, but since we're running this as a service, we're actually in fixed list. So let's go in there. So it's done building. We can verify by checking build/libs, and there's our jar file. So it's ready to be used. Let's try to edit this. I'm assuming bin is relative to here, but it's not. Bin is relative to the root. So let's go here. Okay, and then we got to change cluster name. So our cluster name in this case is my cluster. Mode is fixed list. And then we don't need these because we are in fixed list. So I believe we just need notification member. And this is going to be 127.0.0.1. Port that, and then I think we need, I think in the specification there is, if I remember, if I control F, yeah, here we go. So this is, yeah, you can see the scroll bar here. So we are not that far into the file. You can see it says essential if multicast, which is what the original config thought we were in. So we can safely edit these out. And we can go to notification member, which we have added, notification member, and JDBC member, or JDBC notification member. So the ones that say essential if fixed list, you need to add those. And then these are if you're running provider mode. So let's paste that, and let's also put in our relevant information. So this will be the same, except it's 2000. Sorry, it's 2001 and 1001. These are the numbers. So you do have to comment these out because otherwise it won't run. Okay, I think that's it. Copy and save, or sorry, just save. Go back to our original. And I believe that is everything. So now it should work. So let's try to just run a simple command to see if it works, I guess. So if I remember this list, yeah, okay. I can run this. It won't do anything because it's just a list. But let's get into our bin directory. So you can see here the executables are here. So let's do gs import and, oh, sorry, just do a list. It won't work, but if the thing is configured correctly, it'll at least try to run something. Okay, so error as expected, but it does give an error, and not just a generic error, but an error that we anticipated. So that means it does find our server and it is up and running and ready to go. So let's continue on. So let's grab that Kaggle data. So hopefully I have it saved here because I don't remember what it's called. Okay, yeah, I do. I have it saved in my history. So we're going to go ahead and download this file. It's just a CSV file. So the reason why we chose this data set is you can see here it's a IoT analytics. So it's perfectly in line with what GridDB is meant to be used for. So it has 3 devices in here, 3 unique devices, B8, 00, and 1C. And the row key is a timestamp. So each second or however frequent these data points go, a particular device will emit carbon monoxide, humidity, etc., etc. And so the one difference when ingesting this data set into our GridDB is the data model for using GridDB is not going to be the same like a SQL database. So we're not going to just have one gigantic table like this one here with, you know, tens of thousands of rows with different devices emitting different stuff. It gets very confusing and it's not very efficient for the GridDB side. So on the GridDB side, instead what we'll do is we'll cut this down to 8 columns, and instead each container name will be the unique device name. So we'll have one device for B8, or sorry, one container / table for B8, one table / container for 00, and etc. One for 1C. Yep, that's basically it. So let's try to clean up our data and we can go from there. So let's head back to chapter 3. Now let's go back to development. We have this GridDB on demand course. Let me clear this. Okay, so let's grab that data set. Let's grab that data set and then let's clean it up. So you can just download here. I am running on a SSH thing, so I just have it already here in my directory. And then we also have this this Jupyter file that you can use, which will clean up your data for you. So right now it's on this GitHub page. So let's just run through what it does, and then we will run it. And then I'll show you the results, and then I'll show you kind of what GridDB expects out of the CSV files you feed into it, and we'll actually run it and see the data in our database. Okay, so if you're unfamiliar with Jupyter, it is a kind of visual Python script kind of idea. So the reason why we use Jupyter is because using, Python is very data scientist friendly these days. So you can put in the CSV as a kind of data frame using pandas here, and it's very easy to manipulate individual columns. So the reason why we want to do this is because we want to change the device into I think we want to remove the device column in totality, because we want to separate them out into individual tables, and we also need to change this time stamp column. So you see here it kind of comes out. This is a epoch time, so it is a valid timestamp, but the import export tool does not like taking in data this way, especially with the exponent e, the scientific notation. So we need to change that. Okay, so this part we can safely skip, but here is the thing. So we have our data frame, the TS column. We want to change that to datetime, which is a Python thing. We want to change it to the Python datetime. So yeah, convert it to the ISO 8601 timestamp format. So it'll end up like this. So it'll transform our data from this, which GridDB doesn't like, into this, which GridDB does like. Yeah, and that's basically it. So we do that, and now we do that, and then we're also going to remove the device column out of this data frame. So now you can see here we're down to just these columns. And then here we are changing all instances of this particular device name into device 2 and etc. with device 3. So basically it's a long way of saying that we're going to create separate tables for each of these device names. And then after that, we're going to write CSV files with these separated out tables. So now, using the data from our original CSV, we're going to have 3 brand new CSV files called device 1, device 2, and device 3. And each of these devices will have the device name stripped out, but it'll be the relevant data for that specific device. Okay, and that's basically it. So let's head back to our shell. I already ran this, so if I go into my import directory here, you can see I have a bunch of files, right? So the idea here is when you want to import data into your GridDB database, you have to have 2 files per container you intend to use. So here we have a file called public device1 properties JSON. So public refers to the database name. So public is the default database that comes in all GridDB servers. So it's available to all users. So we're using that one. And then you also have to have the accompanying CSV file. So basically this is the file that has all the rows that we mean to ingest. And this is basically the metadata that tells this CSV file what it wants, what it needs. So let's take a look at the device 1 properties. So here you can see it actually lists out the entirety of our schema. So it has the TS, the CO, the humidity, all the relevant data. It also has a row key, which is our TS, because it's a time series container. So the row key will be the timestamp. And then it has the miscellaneous compression and stuff. We don't really need that part for this video. But basically the main important things is it has a schema, because otherwise GridDB won't know, right, based on the name, what exactly each column is supposed to be. And then we have the container type, time series, and then we also have the container. So this part is important because this is the container name that we're going to insert into GridDB. And then of course the actual container file is very important as well. Okay, so that one is self-explanatory. Let's take a look at its brother, I guess, the CSV file. So a couple of things here. So this first 2 rows are not necessary to import files that are not first exported from your GridDB server. So these come about when, if you were to export your currently existing containers from your GridDB server and create these CSVs automatically with the tool, it would indeed have these files, these rows on top. So this tells you what time this file was generated and what version and by which user. So yeah, this is here. But the ones that you do need if you're importing from public files is these two rows. So this one with the percentage first, it tells you what the metadata file is. So you have to tell GridDB, hey, pull all the container schema and all that stuff, whatever partitioning and whatever stuff you want, pull it from here. And then the second row, the $ one, this one, it tells you what container, what database and what container name. And then notice that the container names, the column names has been removed because it's redundant. So we have that already in the schema file and it'll just confuse the tool. So after GridDB just expects 4 rows or at least 2 rows. So it expects this percentage and this $, everything in quotations, by the way. And then the next down it has to be the first row of data, and then everything has to be as a normal CSV file. Okay, so the other ones are going to be the same. The last couple of things, I guess. So another thing that was created for this video was we're also creating a device master container. So I think we've explained this before, but it bears repeating. So the GridDB usual data model will be each device will have its own container / table. So if you have each device has its own table that it's just a table with the time and all the relevant data points that it produces, like CO and all this stuff. You'll also have or need a separate table that keeps track of all the sensors. So this will be a collection container most likely. I mean, yeah, it will be, and it'll have all of your sensor information that is needed. So we can take a look at the device master schema first. So this top part, the only part worth noticing is that the collection, the container type is not collection, and yeah, the container name is device master, and you can see the schema is not the same as the other ones. So the schema is just going to be your typical metadata that is required to kind of run your region, I guess. So equipment name, equipment ID, location, stuff like that. And then yeah, the partitioning and stuff is not here. Yeah, because it's a collection container. Okay. And then the last thing we need to look at is this GS export. So, so here is it's telling our tool exactly what information to grab when we want to run our import tool. So here you can see the user is admin, so you are the admin. We want to import 4 containers of CSV files. And here we go. So we tell it explicitly, all right, we want device 1 and we want you to use this metadata. We want device 2, we want this, etc. Then we also use the word, the name, the database name. Okay. That's basically it. So if you wanted to, for example, grab this data and import it into your server, you would download that, and then yeah, you would clean whatever is necessary. So you can use these kind of Python scripts, or you can use Excel, you can use whatever you like to, easiest way to massage the data into kind of the way you want it. And then you just got to make sure that your directory has enough of the metadata in there for it to work. Okay, so now let's actually run this. So let's head back to our area that has everything. So bin here, and then let's try to there we go. So this is the command. Okay, so gs import is in our directory already, so that's why I'm calling that. It's in the bin directory of your export import tool. You have to put in your credentials, username and password. That's what I'm doing here, and then I'm putting in the directory that we're using. So I want to import. So do you remember earlier we were in the import directory here? So I want to import everything that is within that directory. So it'll first read through this gs export JSON. It'll make sure that all the files that are listed in here are within the same directory, and then it'll run through and actually read the metadata here, read the metadata, read the schema, find the CSV, make sure it matches, ingest everything, and so on and so forth. Okay, so let's run this, and hopefully it imports everything that we want. Container already exists. Device 1 already exists. Okay, that is no problem. So we can drop container, device 3, device 2, device 1, and device master. Okay, now going back. So that was the GridDB web shell. Okay, so now let's try that again. Import number of containers 4, which is that's what our metadata said. So 187,000 rows in device 1, 111,000 rows in device 2, 105,000 rows in device 3, and 3 rows in device master. Cool. Import completed. So now what we can do is we can try running a search container, and this will show all the devices, all the containers in our GridDB server. So we can see the newly added devices that we added with the import tool, device 1, device 2, device 3, device master. They're all here and ready to be queried. So I guess for now we can do a show container device 2 just to make sure that everything's in place. So the schema looks fine. It looks like to match exactly what we saw on that Kaggle website. And then we can see that the compression and row expiration data is correct, as in doesn't exist, as in we didn't tell our metadata to add these features into our container. And last, we can try to query them or query one of them. So let's query device 2. Run that, and we can see here we grabbed 111,000 rows in 16 milliseconds, which matches the import tool we saw earlier. And that'll do it for this video. Thank you so much for watching.